Hello and what's up to you all matriculants. My name is Abram and today we're here to learn more and learn extra on geography, a show that is proudly sponsored by Macmillan. Thank you so much Macmillan for all the resources and the support you're giving us and giving all the learners that are watching right now. Well, today I'm not alone, I'm with Kamlin. Kamlin, how are you?
Abram, guys, you can feel that energy. We're almost there. Are you ready? It's Mapwork, Geography Paper 2. Thanks, Abram. We're ready to go.
We're ready to go. Well, you're making the mindsetters to panic now. Already they've been panicking. So when you're saying that we're almost there, you're like, guys, get more nervous. But that's not what we're saying. We're here to say, relax. We're here to give you all that you need to know. There's notes that are available for you guys, the viewing and the downloading option. Only you can go on our Facebook page. It's facebook.com/learnextra. We post the notes for you guys. Otherwise, if you want other notes, like the previous shows, you can go to learn.mindset.co.za. Guys, all the resources are here for you guys. Otherwise, before I give over to you, Kamlin, I must say, guys, let's help one another on the page. Bring all your questions because we are a team and together we can do this.
Thanks, Abram. Teamwork, guys. Almost there. You've just covered your theory. Now we're ready to go with map work. And are you working with those maps? We've been covering the whole day today, ensuring that you are ready. Today we've got calculations. Question 2, 20 to 25 marks, which you're going to master today. We're going to cover all the calculations. But before we go there, let's look at an outline of what we're going to cover today. In today's section, we're going to be working with the interpretation. Let's get that back. The interpretation and analysis of topographic maps. We're also going to be calculating the area, magnetic declination, true bearing, coming together to calculate the magnetic bearing. Grid referencing. We've worked with this throughout. Remember, your degrees, minutes, and second, also referred to as exact position or coordinates. We're also going to be looking at the average gradient. Further to that, vertical exaggeration. And today, we will be drawing a cross-section. This is a section you've been asking for, and we're going to show you exactly a step-by-step process on drawing of a cross-section. Not only that, we're going to look carefully into every calculation and how you approach it in a step-by-step process in order to get the answer right. Let's look at, firstly, some of the aspects of GIS that you should know at this stage. GIS questions. Now, GIS questions is your question 4 of the Mapwork paper. I've chosen to highlight this at the very beginning in order for you to ensure that we are ready for question 4. So, when you're revising for Mapwork, note the following. Know and remember your terminology and concepts. Simple concepts like data layering, data management, data manipulation, as well as data standardization are essential for you to name and define, especially in question 4. Looking further on, always refer to the map and photograph when answering applied GIS questions. GIS questions can bring knowledge about theory on a very elementary level. And what have you been covering today, guys? The climate of an area, climatology. The general gradient is gentle, geomorphology. The human and social factors of location, which is settlement geography. And of course, economic impacts of development in a specific place, economic geography. As you can see, the integration of GIS from theory, as you've been doing for the past hour, will be also required in your Mapwork paper. Your Mapwork GIS brings together that knowledge that you already have into the Mapwork paper for you to apply that knowledge on a map. Now, guys, let's get straight into the calculations and note the following. I want you to write these steps down. Whatever method you have followed, your teacher has taught you, and if you have mastered this particular method, it is fine. What I will give you is the methods that are alternative to the ones you are working with. essential. You need to get to the same answer, and that is crucial in order for you to get the full marks. Let's look at what calculations we've got up first. The first calculation we'll be working with is area. Let's look at the question. Calculate the area of block C2 on the topographical map of Parys. As we've said, today we'll be working with the topographical map of Parys. Doesn't matter what topographical map you are working with, all have the same blocks as all other topographical maps, which simply means that your lines of longitude and latitude are equal, because we are working with 1:50,000 scale maps. So let's look at this calculation. Any block has lines of latitude and lines of longitude. Note always, when we're calculating the area, this would constitute A on the latitude, which is your length, and B on the longitude, which is your breadth. Let's look at the calculation carefully. We must start with a formula. Area is equal to length times breadth. So what that simply means is I would have to measure the length of a block on a map. And that means simply the measurement from one longitude to another longitude gives me my length. The measurement of one latitude to another latitude gives me my breadth. Already I have measured this for you. You will note the length, that is the distance from this point to this point, is 37 millimeters. The breadth, as is measured, is 33 millimeters. Why am I using 0,05? Now, as in previous lessons, I've urged you, measure the distances on the map in millimeters. This offers you a more accurate calculation. So because my scale is 1:50,000 and I'm measuring on a map with millimeters, my scale becomes 0,05. You should note, if I measure in centimeters, my scale is 0,5. So any calculation will be determined by the unit of measurement on the map. I'm using the example of millimeters. And in this case, because it's millimeters, I will multiply by that scale of 0,05. What I do to the length, I will do to the breadth. I've already calculated it. This converts to 1.85 kilometers. 37 times 0,05. 33 times 0,05 is 1,65. Note, because I have measured in millimeters, and when I multiply by 0,05, my answer is expressed in kilometers. Hence, 1.85 kilometers multiplied by 1.65 kilometers is 3,05 kilometers squared. Kilometers squared, how did we get that? A kilometer times a kilometer is kilometers squared. This is an easy calculation. You should note that your accuracy will determine how good and correct your answer is. So I can't see you getting this answer incorrect, only if you've measured accurately and you've performed your steps, written down your steps as I have shown you. Let's move on to the next calculation. And you've asked for it. This is especially for Brian, magnetic bearing. We're still on the topographical map of Parys, and the question is, calculate the magnetic bearing of trig beacon 31 in block E3 from trig beacon 706 in block C2 for the present year. Crucial elements that you should note are as follows. Whenever we are calculating magnetic bearing, the formula is magnetic bearing is equal to true bearing plus magnetic declination. My true bearing will be measured with a protractor. My magnetic declination has to be calculated with information from the map. And note, it's always going to be the present year. So immediately I should know I'll be taking the year on the map and subtracting it from 2014, which is our present year. Let's look carefully at this calculation. I've got my map, an extract of the map, and I've got my 2 points, 706, as well as trig beacon 31. Now, if I look at it carefully, back to the question, and I'm going to use another color here, of trig beacon 31 from trig beacon 706, immediately I am calculating my true bearing. From the question, I have to determine which is my from point. My from point is therefore trig beacon 76. And I will then draw a line to the other point. So let's look at what you'll have to do on your map. Because my from point is trig beacon 706, I draw a straight line at the from point. That would be step 1. Step 2, I draw a line, and I'm going to try and draw it as accurate as possible. Let's get that out. I'm going to get that line drawn again for you. And we're there. So let's get it in pink. A straight line at the from point and a line joining the 2 points. Now, note the following. I will use my protractor to measure that angle. That angle is going to be my true bearing, dependent on which side of the true north line your other line joins. Simply put, there's my true north line. Let's get another color. There's my true north line. There's my line joining the other point. My true north line and my line joining the other point. So, if I measure this angle, my point is to the east of the true north line. And I will measure it as normal. And remember, the degree would be less than 180 degrees. If my point was to the west of the true north line, the angle will have to be greater than 180 degrees. So, I've already measured the true bearing for you. But what is key and essential is the steps to follow. Step 1, a true north line, which is a straight line at the from point. Step 2, a line joining the other point. And simply step 3, measuring the angle with a protractor. Let's look at the calculation. And we'll get to the calculation now. Down there. And there we are. Okay. Let's get back a bit up first. And when I measured the true bearing, my angle was 170 degrees. And note, I've given it a direction, south-southeast. What this means is that in terms of the angle, I've measured with a protractor. And in terms of the direction, I've given it in degrees. Let's go further. Once we've established the magnetic bearing with its formula, which is true bearing plus magnetic declination, step 1 would be to calculate the true bearing, which we've done. Let's move on to step 2, which is the magnetic declination on the map. And to do this, we take the mean magnetic declination, which is on the map, and the year is given as 2001. A lot of you tend to make the mistake of using the incorrect year. Now, here's the tip that you should remember. You always take the year immediately after the mean magnetic declination. Simply put, normally it is given immediately after the mean magnetic declination. I want you always to remember and note the following. Normally you would get year in brackets, 2001 to 2007. Please, guys, discard that year. Take the year immediately after the mean magnetic declination for an accurate answer. Let's go back to our calculation. I've extracted it from the map, and it's 23,7 degrees. And note, it's not 23 degrees 7 minutes. It's 23,7 degrees, which is going to influence our final calculation. And of course, that 27,7 degrees is west of true north. Again, information from the map, the mean annual change. And the mean annual change on this map was 3 minutes westwards. Immediately in your mind, you've got to remember, Whenever the mean annual change is westwards, we will add. If it's eastwards, we subtract. Where? In our mean magnetic declination. Good work, guys. The year on the map, which was immediately after the mean magnetic declination, was 2001. The 3 steps that I've given you up to this stage is information on the map, and it's easily extracted for you to score the marks. Now let's get into the actual calculation. The first step, the number of years. In order to determine the number of years, you take your present year and subtract it from the year on the map. I get an answer of 13 years. 2014 subtract 2001. The present year subtracted from the year on the map gives me 13 years. With that, I can now calculate total change. Total change is 13 years, which I've calculated from my number of years, times 3 minutes westwards. What am I doing, guys? I've calculated the number of years by taking my present year, 2014, and subtracting it from the year on the map. 2014 minus 2001 is 13 years. To calculate the total change, I bring down my total change, which is 13 years, and my mean annual change, which is 3 minutes westwards. Let's look at the answer. 13 years times 3 minutes westwards is 39 minutes. Now, in previous lessons, I've told you, whenever you get an answer for your total change, it is years per minute. You've got to convert that answer to a degree and a minute. In this example, we've got 39 minutes. How many degrees and minutes are there? Correct. It's 0 degrees and 39 minutes. The moment an answer in the total change is greater than 60, you already have 1 degree. In this example, you have less than 60 minutes, so therefore, your degrees is 0 and your minutes is 39. And hence, this answer is my total change. I now carry this answer forward for the calculation. Magnetic declination for 2014. Note my mean annual change, which is 23.7 degrees, added to. Why do we add? Because our mean annual change was westwards. To my total change, 0 degrees and 39 minutes. Let's get another color here. How did I get this, guys? 23 degrees and 42 minutes. In this example, we've got 23.7 degrees. When you have a comma degree, you should note that the figure after the comma, which in this case is 7, must be multiplied by 6 in order to convert it to degrees and minutes. The 7 is not a minute. It is 23.7 degrees. And some maps use this type of calculation. So I'm bringing it to your attention. If you get a figure after the comma, in terms of degrees, you've got to multiply that figure, in this case 7, by 6 in order to convert it to degrees and minutes. Now, when we've converted it, 23 degrees, 42 minutes, note I've multiplied the 7 by 6, added to my total change. And this makes the calculation much easier. 23 plus 0 remains 23. 42 plus 39 remains 81. Now, the golden rule, 60 degrees is equal to 1 minute, 1 hour, or 1 degree. So, in this example, we've got 81 minutes. And therefore, we have to convert the 81 minutes to degrees and minutes. How do we convert? How many times does 60 go into 81? Once, remainder 21. And hence we have the answer 24 degrees and 21 minutes. How did I get that? I asked myself, how many times does 60 go into 81? It is 1 time. I bring the 1 over to my degrees and remainder 21. And this is simply your magnetic declination. And this now is taken forward to calculate the magnetic bearing. Let's look at that calculation. Magnetic bearing is equal to true bearing plus magnetic declination. My degrees on my true bearing was 170, which I used my protractor to calculate. My degrees on my magnetic declination was 24 degrees 21 minutes. When I add the two, I get 194 degrees and 21 minutes. Guys, this is a detailed calculation. I hope you've written them down, and please get Abram firing with those questions. And with that, we're going to take an ad break. What do you think, Abram?
I think so too. Already there are so many questions, and thank you guys. After the break, I'll be telling you more about the giveaways that we have as well, so stay tuned. Welcome back, Mindsetters. Great news. I know that by now you should be knowing this. We're having this awesome competition. It's Be a Bright Spark. It is a competition where we're giving away a Chevy Spark. So all you need to do, it's simple 3 steps. 1, you buy yourself this awesome official Safeways K53 Learners and Drivers Manual, or download the cool app from Google Play. Secondly, like our Facebook page, which is facebook.com/learnextra, and also like the Safeways Facebook page, which is facebook.com/SafewaysK53. And lastly, the third thing you need to do is to enter your details by filling in the entry form that is found on our Facebook page on Learn Extra. That's how simple it is. You'll get it on a tab which is written Win a Chevy Spark L. That's how simple it is, guys. So get yourselves the copy or download the app, and then you could be the winner of that Chevy Spark. We've got only 3 weeks left, guys. So on the 15th, we're closing. 23rd, it is the final day where we're announcing the winner of the Chevy Spark L. It could be you, so enter right now. But other than that, Kamlin, we've got some questions for you.
Excellent. Let's hear them.
You've asked for fires, so yeah, the Mindsetters are fired.
Oh, good.
Right. Tanta says, in magnetic declination, what do we use the year in the brackets for if we're only using the one that comes first all the time?
Okay, Ntlantla, golden rule, and I can feel those geosparks flying. The golden rule is use the year immediately after the mean magnetic declination. Do not use the year in brackets. That year shows you in terms of when the particular map was developed and the time period in which it will exist. It obviously is not a year which can be used in a calculation. Therefore, the golden rule, immediately after the mean magnetic declination, is the year which you use to calculate your number of years. The next spark.
Right. Next one is from Lungiswa. On magnetic bearing, how far should the true north line be measured?
Good question. Your true north line will be determined by the other point. Remember, in true bearing, you've got 2 points. The from point and the other point. We're always drawing our true north line at the from point, which is a straight line. I would suggest that you draw that line dependent on your protractor. Remember, in this example, I have not used a protractor. I have calculated it already. But on your topographical maps, you must be able to draw the lines in order to measure. So the length of those lines will determine how accurately you use your protractor. So in Tlantla, draw a line that is equidistant, equal in distance to the line drawn to the other point. Next one.
Okay. How can we calculate true bearing? That's from Israel.
Okay.
And another one, maybe you can take these ones. How do we respond when the mean annual change is eastward? That's from Katleo.
Katleho, and I believe Immaculate as well, asked that question.
Yes.
Excellent question, guys. The golden rule that we've been preaching, and you've got to instill it. Lock it up in that. Westwards, add. Eastward, subtract. Let's do a quick example of if this particular map had a 3 minutes eastward, how would the calculation have changed? Now, I'm going to erase all this for you and do a 3-minute eastward calculation. Okay, well done. Let's look at it. So the number of years remains. It still remains 13 years, and note that 2001 was immediately after my mean magnetic declination. This remains as well, because my 3 minutes remains. However, we are changing this question to accommodate eastwards. And remember the golden rule. Eastwards is subtract, westwards is add. Now here is where the impact of our change will come through. So I've got 23 degrees and 42 minutes. Subtract. Why? Because we've changed our mean annual change to eastwards. 0 degrees and 39 minutes. Now, degrees to degrees, 23 minus 0 is equal to 23 degrees. 42 minus 39 is 0, 3 minutes. Note how easier that calculation has become. There are less conversions as opposed to the westwards. What do I do with this answer? Let's erase now the magnetic bearing. And calculate. So 170 degrees plus 23 degrees and 3 minutes is equal to 193 degrees and 3 minutes. Note the difference in the answer between eastwards and westwards. Now, a lot of you are getting the confusion where to use the subtraction. Your rule is magnetic bearing is equal to true bearing plus magnetic declination. That is a formula and it cannot change. The subtraction or the addition comes into play in this part of the calculation. When we're calculating the magnetic declination, this particular sign, where I take my mean annual change and add it to my total change, will be determined by whether it's east or west. And that, guys, is simply the rules which you have to remember. This is a calculation which determines the position of the Earth in relation to the North Pole. And note, the North Pole is not fixed. We have a magnetic north and a true north. And therefore, the declination is calculated. So for every point on the Earth's surface, we have to calculate our position in relation to the magnetic north as well as the true north. In this example, I have not used a protractor. I am taking you step by step in order for you to see how the calculation will be set out. How's that, Abram?
That's cool.
Can we continue?
Yes, sir.
Excellent. Guys, let's move on. We've got a lot of calculations to do, and I'm going to continue with the next calculation, which is grid reference. Now remember, grid reference in this case is the position on a map in relation to the longitude and latitude. So my answer must be in degrees south as well as degrees east, because our position is in relation to the equator as well as the Greenwich meridian. I will take you through the step-by-step process. There's our point, and remember, again, we are using trig beacon 706. Now, always note that the line of latitude is to the top of the point. The line of longitude is to the left of the point. Apologies, left of the point. When we are calculating, we should calculate the position of the point in relation to the first line of latitude, which is the top, and the first line of longitude, which is to the left. How do we do this? Before I take you through the steps, remember your distances are measured from that line of longitude to the point. That will determine my longitudinal position. I'm just going to write long. My distance from the point to the latitude, the first line to the top, will determine my latitudinal position. Now, let's look at the calculation. And again, I'm going to take you through the step by step in order to determine the latitude and longitude coordinates. Now, I'm going to go to the map of Paris, and I'm also going to pan in to determine how far we can go with this particular map. Now, if you look at this map, in terms of what we've seen, you'll note that at this particular area, you have your latitudinal coordinates, which is 26 degrees and 52 minutes. That means that this line running at the top is your 26 degrees and 52 minutes. That's followed by 26 degrees and 53, 26 degrees and 54, 26 degrees and 55. These are latitudinal lines. Note the longitude is 27 degrees and 23 minutes. Hence, 27 degrees and 24, 27 degrees and 25, and so on. So let's get back to the calculation. In order to determine the latitude, we've now calculated the latitudinal position, and that is 26 degrees and 54 minutes. How did I get that? I went to the point, I went to the line from the point, and then I read the line across. That would determine the latitude. In order to determine the longitude, to determine the longitudinal position, remember, as I've instructed you, you will then go from the point to the first line of longitude and read it off as it is. And in this example, we've determined 27 degrees and 24 minutes. Now let's look at the steps. Calculate the distance and time between the point and the line of latitude directly above. Now, here's the calculation. Let's go back to the map and explain that. I'm going to erase all these markings so that it makes sense to you in the end. Now, I am calculating the latitudinal position. My point is 706. To determine the latitude now, I would then measure the distance from that point to the line. Once I've done that, I will then measure the point and distance between two lines of latitude. Note, the distance between two lines of latitude will be in millimeters. The distance between the point 706 and the same line of latitude will also be in millimeters. Let's go to the calculation. Now, the distance between the point and the line was 23 millimeters. The distance between two lines of latitude was 37 millimeters. Why do I multiply by 60 minutes, 60 seconds? Remember, the distance between two lines of latitude is 60 minutes, 60 seconds, which is 1 minute. When we calculating this, you must remember that 60 seconds is equal to 1 minute, which is the distance between two lines. Now, a simple multiplication. 23 times 60, 37 times 1. 23 times 60, alternatively divided by 37 times 1, will give me 37 seconds. On your calculators, guys, 23 times 60 divided by 37 will give me an answer of 37 seconds. What do I do to that? Remember, we've calculated our latitudinal coordinates as 26 degrees and 54 minutes. When I go down, I've carried that answer over here, and I've added my seconds to it. The same procedure would follow when we're calculating the longitude. Note, calculate the distance and time between the point and the line of longitude directly to the left. So, let's go back to the map. And I'm going to use the green color here. Again, my point. And note, the distance between the line of longitude and the point is measured in millimeters over the distance between two lines of longitude. Hence, my calculation, 26 millimeters, 31 millimeters. And I will multiply by 60 seconds. Why? Because the distance between two lines of longitude is 60 seconds, which is equal to 1 minute. Hence, my calculation, 26 times 60 divided by 31. 50 seconds. What do I do with that 50 seconds? I carry it over to my line of longitude. Note, when we came to the longitude, we got this line, and therefore, that answer is carried over to the calculation to give me a final answer of 27 degrees, 24 minutes, and 50 seconds east, Why? It's a longitude. Let's just go back to my latitude, 26 degrees, 54 minutes, and 37 seconds south. Why? That's my latitude. This is a calculation which shows you the accurate position of a point, for example, a trig beacon on a map and its relation to the latitude and longitude. Let's go to the next question. One famous question that all of you have been asking for is gradient. Now, pay careful attention to each and every step in order for you to get this accurate and answer it well. So, the question simply reads, calculate the average gradient between trig beacon 31 as well as trig beacon 706. Now, we use the same points, and let's look at the calculation. Now, the calculation of gradient is simply the distance between 2 points over the height as well. So my formula is vertical interval over horizontal elevation. A lot of you use the formula gradient is equal to height over distance, which is again, guys, acceptable. Simply put, you should note that you are calculating whether the slope is a steep slope or a gentle slope. How do we determine this? If we are looking at a map, we look at the spacing of the contours. You should note that when the contour lines are close together, it's a steep slope. When the contour lines are far apart, it's a gentle slope. But in order to calculate the average gradient between the 2 points, we have to work out the difference in height as well as the difference in distance. Let's look at this calculation carefully. For my vertical interval, or remember, we've also got the term height. You should note we are calculating the difference in height between the 2 points. In these 2 points, we are using trig beacons. Now, where is my height on a trig beacon? We've discussed this before. The height is always given below the trig beacon. Okay? Remember, the number of the trig beacon is not its height. Okay, and it's always indicated in heavy print. The height is always given at the base below the triangle. Let's look at the difference in height. In this example, I've got 1456,4. Remember, it's in meters. That is one height, and the lower height is 1390,1. In this example, I've calculated it to 66,3. What are we doing? We are taking the heights of the 2 points on the map. The higher height subtracted the lower height. And in this example, we've taken the 2 heights and we've got the answer of 66,3. Already I've worked out the vertical interval for my calculation. Now that has given me the height, I need to calculate the distance, which is my horizontal equivalent or elevation. Let's look at how we calculate that example. Horizontal elevation or equivalent is the distance between the same 2 points on the map. I have measured the distance already, guys. Look at the distance, 73 millimeters. Again, I am saying you've got to measure accurately. So 73 millimeters is the distance between the first trig beacon and the second trig beacon. Now, what do I do with that? I multiply it by 0.05 to convert it to kilometers. And my answer on the calculators would be 3.65 kilometers. But note, and I'm going to do this for you, the answer for the vertical interval is in meters, which we've calculated. So therefore, my answer for the horizontal elevation or equivalent must also be in meters. So I've converted to 3.65 kilometers. To convert that to meters, I multiply by 1,000 on my calculator. And that would give me an answer of 3,650 meters. Now let's look closely at how we use our formula. Note, gradient is equal to vertical interval over horizontal elevation, or as we've alternatively said, gradient is equal to height over distance. Now, we've worked out already our vertical interval at 63,3 meters. We've worked out already our horizontal elevation or equivalent at 3,650 meters. Now note, gradient is a ratio. And in order to calculate a ratio, we have to get an answer for the numerator that has to be at 1. What is the numerator? The number on the top of the fraction. So, what I do to my numerator, I need to do to my denominator. To get an answer of 1, I need to divide the numerator, which is 63,3, by itself, 63,3. That would give me the answer of 1. A general rule in maths is what I do to the number at the top, I must do to the number at the bottom. So 3,650 divided by 63,3 would give me an answer of 57,6. What does this mean? My ratio, which is in a fraction, now becomes a ratio of 1 is to 56,6. This simply means that it is an answer which must be expressed as a ratio, because gradient tells you in terms of a steep or gentle slope. When you come back from the ad break, we will then discuss further what you can do with gradient in terms of explaining further concepts. Back to you, Abram.
Thank you so much, Kamlen. So much to be said, and so many questions are also coming in. Guys, I would say this one more time. Let's help one another on the page, because some of you do have the answers. So it's about teamwork. But remember, also, during this break, we've got another awesome giveaway on top of the car, guys. Tomorrow, it's the closing for the competition, a small competition that we have, which of which you can stand a chance of winning a Google voucher worth 150. All you need to do is to go to facebook.com/ Safeways K53. On that page, on top there is a pinned post. All you need to do is to caption that, get your friends to like your comment, and the comment with the most likes gets to win that voucher worth 150. We'll see you after this break. Welcome back, Mindsetters. Thank you for your questions and your comments on the page. We really appreciate it. Kamlen, back to you.
Thanks, Abram. Guys, I'm happy that those questions are coming in. Abram, are there any questions on gradient?
Yes, there are.
You want to give me a few?
One from Katla was saying, how do I know that my gradient is for a steep or gentle area?
I'm going to answer that question right now. Let's look at it. And there's the question here. I'm going to look at both at the same time. Is this gradient steep or gentle? But before we go there, let's look at the next question. Explain this ratio. What does this answer mean? Guys, when we're calculating gradient, and remember, for you budding civil engineers out there, for you budding quantity surveyors and land surveyors that want to do this profession, this type of calculation will become important. What does the answer 1 is to 56,6 mean? It tells you simply the following. And I want you to write the statement in your book to remember it. For every 56,6 meters in horizontal elevation, gradient increases by 1 meter. Now the golden rule is as follows. If the distance is small, it means the height is increasing quicker. If the distance is large, the height is increasing in a longer space of time. What do I mean by that? Let's draw a diagram. This simply means that for every 56 meters, the gradient is increasing by 1 meter. Another 56 meters, and the gradient increases by 1 meter, which would suggest that, and another 56 meters, 1 meter. So, notice the steep slope. Hence, when my number is less than 100, the average gradient is steep. Note we are saying average gradient. Average gradient is steep if the answer to that ratio is less than 100. What if the average gradient was gentle? That would mean that this answer here has to be greater than 100. Simply put, if we have to walk 100 meters for 1 meter increase and a further 100 meters, and it actually goes off the board. So notice the difference. The golden rule, if the answer is less than 100 meters, your gradient, your average gradient is steep. If your answer is greater than 100 meters, your average gradient is gentle. What I'd advise you to do is look at the contours, look at the spacing, the golden rule. When the contour lines are close together, steep slope. Contour lines far apart, gentle slope. Let's look at the next question. And this one's for you. We asked, is this gradient steep or gentle? And the obvious answer is steep. Why is it steep? Because my answer is 56,6, which is less than the 100 meter, which determines the average gradient being steep or gentle. How's that, Abram?
That's cool.
Have we got enough on gradient?
I'm not sure if this one falls on that one, but how do we know which line go when determining your latitude and longitude?
Okay, but we've covered that already. Remember, the line to the top is your latitude, the line to the left is your longitude. Write that down and remember it. I need to continue, guys, because we haven't got enough time. So I'm going to quickly walk through cross sections. Let's look at cross sections, and I'm going to briefly explain this to you in a step-by-step process. So, step 1, we are asked the question, draw a cross section between point A and point B. Any points on a map, and these could be trig beacons, contour lines, benchmarks, and so on. What I've done is I've extracted a sketch for you to show you that this could be a possible block in a map. Here's point A and there's point B. On your map, you will note that we've got contour lines, guys. And each contour line has a specific height. And I am asked to draw a cross-section from A to B. Notice, and let's get this in another color pen, notice the steepness of the slope here. Notice the gentleness of the slope here. From A to B, you'll note that the heights are increasing. Let's get that in another color for you. From A to B, the slope is gentle. And as we move closer to B, the slope becomes steep. Okay? Now this would be a rough cross-section of any map. Look at that, guys. What have I done? I have taken a strip of paper. There's my strip of paper. Placed it on the line. In this case, my line A, B. And I've marked off each and every, let's get that in another color, each and every contour line on my strip of paper. What I've also done is included the heights. So in your exam, when you are drawing a cross section, you will not be asked to draw many lines. All you have to do is take your strip of paper, draw a line on your map between the 2 points, place the paper on top, and mark off each and every contour line. And in this example, you can see my strip of paper has marked off each and every contour line, and I've also indicated the height of each of those contour lines. Notice how I'm constructing my cross-section. Step 3. Now, in this example, what I've done is I've placed my strip of paper at the bottom of my cross-section. And now I've plotted the points. Note, in this particular y-axis, there's my y-axis. There's my y-axis. And here is my x-axis. At the bottom of the x-axis, I will place my line with all the points that I've already marked on my strip of paper. Note, I have included the heights of the points as well as all the different points. And guys, to finally put it, that's what my cross-section looks like. A nice gentle slope, a steep summit, and a flat plane. Now guys, we've run out of time, and I want you to remember, you've got to practice, 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 and at this stage, get a good night's rest, and all the best for Geography Paper 2. I know you're going to do well. Good luck. And back to you, Abram.
Thank you so much, Camilin. Thank you guys for tuning in, and all the best for tomorrow. Remember, at 7 o'clock, watch a video of me and Jerome talking about the importance of a driver's license and the issue of buying driver's license. We love you guys, and peace.